I just wanted to take you through what we've been through so far. We've looked at working out moles from relative atomic masses. So we've looked at adding up all the atomic masses of a compound and what that makes. Then we've looked at what a mole actually is. Then we've calculated the number of moles using mass in grams divided by the molar mass, and rearranged that to find mass. So molar mass times the number of moles will give you the mass. And we looked at that triangle. So that's the sort of first page in the textbook, first pages. Then we looked at using equations. So hydrogen plus chlorine, hydrochloric acid, then you need to balance it. So that's a skill we've practiced. And then we looked at using balanced equations to work out reacting masses. So this example I gave you, where the sort of question they can ask you is, if you have a solution containing 100 grams of something, what other reactant do you need? So you've used one reactant to work out the other one to create this product. Okay, so that's one type of question, working out the masses of reactants. Okay, so mass calculations using balanced equations. This next bit is what we're going on to today. So masses, balanced equations, but it's a little bit more difficult, and it's a thing called limiting reactants. So as it says in there, more often than not, when you carry out an experiment, you don't use exact amounts. So you would have one thing that's what we call in excess, and one thing that's a limiting reactant. So I'm going to go through the example there with you today, and then you're going to have a go at a few more. So when you talk about limiting things, something that the limit is when it stops something. Excess is when there's way too much of it. So a good example of a limiting reactant is fuel in a car would be the limiting reactant, and oxygen in the air would be in excess. Because there's an abundance of it. Okay, you don't fill your car up with oxygen, but you do need it for the fuel to explode, and then this is the limiting factor that costs a lot. There are loads of other examples of that. So one is in excess and one is the limiting factor. So this is an example of when you've got magnesium in here, ribbon, which we've used before, and then if you put that with hydrochloric acid, you get a reaction. Magnesium plus 2 HCl, so I've already balanced it for you, gives you, so a metal plus an acid will give you a salt plus hydrogen. This is the balanced symbol equation for that, and you're just worried about these two things in this question. So it says 4.8 grams of magnesium ribbon reacts with a solution of hydrochloric acid containing 7.3 grams. The way you work that out is 4.8 grams divided by 24 gives you the moles of magnesium. Then you work out the moles of hydrochloric acid, so 7.3 divided by 36.5, and then 7.3, oh yeah, I've just done that again because it's going to do 35.5 plus 1 equals that, and then that gives you 0.2 moles, but then what you need to do is times 0.2 times 2 equals 0.4 moles for HCl, because you've got up here 2 HCl. Okay, so Mg, you've just got one of them, so you did 4.8 divided by 24, which is the molar mass, so it's mass divided by Mr, the molar mass, equals 4.8 divided by 24 gives you 0.2 moles of magnesium. 7.3, so we've just worked out the mole of one of these. 7.3 divided by 36.5 gives you 0.2 moles, but you times that by 2 because up here it was 2. Okay, so have a go at those practice questions today.